Hello everyone, let us now discuss some problems related to line integrals. So let's have a look at our first question, which says that if f is given to be 3xy I cap minus y square j cap, then you are to evaluate the line integral of this force f corresponding to the distance dr over the closed curve C, where what is C? It is not closed, it is not given closed. Okay, the curve C is the curve which is given to be y is equal to 2x square in the xy plane, and we have to take this curve from the point 0 0 to the point 1 comma 2. So let us move on to its solution. For its solution, so we require two things. Firstly, you should know what is this curve C here. For that, we have to look for this curve y is equal to 2x square. All of you know that this is nothing but this is the upward parabola. So for this upward parabola, let me draw it over here. So suppose this is my coordinate axis. So your upward parabola would something be like this: y is equal to 2x square. So that means it would be more steeper than the original parabola having vertex at origin. Now, but your curve C, that is defined from the point 0 0 to the point 1 comma 2. So the point 0 0 on this curve lie here at the origin, and the point 1 comma 2, suppose this is the point at a distance 1 on x-axis and the distance 2 on y-axis. So this point is 1 comma 2, and I am calling this this point as point A. So our curve C would be from this point 0 0 to the point 1 2. So that means we are traveling from this point 0 0 to this point 1 2. So this is our curve C that we are to look at. Okay, so here we are to calculate the given integration C of the vector f dot with dr, such that this C is the red curve which I have drawn over here. Now here, because this is x-axis, this is y-axis, so we are in two-dimensional plane. So before writing this down, I have to determine what is my dr vector. So r vector, I can define this to be the position vector in the 2D plane. So in the 2D plane, what could my vector look like? It would be xi cap plus yj cap. If this is the vector, then according to that, what would be my dr vector? So dr vector, that would be equal to dxi cap plus dyj cap. So this is simple. Now we will write whole of our curve in terms of parametric equations. Why? Because it would be more easier to solve that way. So let me first define it in terms of x and y, and then we can convert it into the corresponding t curves. So accordingly, our integration over C for the vector f dot dr vector, what would be this? It is integration over C of the function 3xy I cap minus y square j cap. This is given to us. This is vector f dot with dr vector. So that is dxi cap plus dyj cap. So this is our vector. So now we can perform this dot product. So it would be 3xy dx minus y square dy. So this is our integration. Now here, because you see the integration here is with respect to x, and we also have the variable y here, this portion is fine. So what we can do here, in order to solve this integral, we can convert this particular term to some another parameter, say t. So how can we convert that? We can write, we convert it to some other variable, namely t. So for doing that, we can define the parametric equations. Now we know this equation for the given curve is y is equal to 2x square. This is the given equation of C. So here if I assume x to be equal to t, this implies y would be 2t square if I substitute this quantity here, right? So this is my x in terms of t, this is the y in terms of t, therefore these becomes the parametric equations of the given curve. And according to this parametric curve, we have to see the variation of t. Here if you notice that the value of x goes from 0 to 1, so the value of y goes from 0 to 2. So that means in this case, because x is equal to t, so that means the limits for t, they will go from the point 0 to the point 1. So that will satisfy our given equations. So we can say the points here 0, 0 and 1, 2, they correspond to the point t is equal to 0 and t is equal to 1, because x is equal to t here. And moreover, we now have the values of x, we now have the value of y, we have the limits, but what about this dx and dy? So we also have to calculate them. So when you calculate this, when you differentiate equation x is equal to t, you have dx is equal to dt, and when you differentiate the equation y is equal to 2t square, so you have dy is equal to 4t dt. So you can substitute these quantities into the given integral. So let's see what do we get after we substitute all these values here. So after substituting, our integration is now over t from the value 0 to the value 1. Instead of x we will write t, instead of y we will write 2t square, instead of dx we will write dt, minus instead of y we will write 2t square, so we have y square this quantity, and dy we will write 4t dt. So this is our integral. Now we have to simplify this and we have to solve this one. So it would be 6t cube minus, you have 4t to the power 4, not 4, actually 8t to the power 5, yes, into dt. And the limits of integration, they vary from 0 to 1. So we have to perform this integration. It would be 6t to the power 4 by 4 minus 8t to the power 6 by 6, and the limits of integration, they are from 0 to 1. So when you substitute the limits over here, this would be equal to 3 by 2 minus 4 by 3. Yes, that is it. So when you solve this quantity, what do you obtain? You have to take the LCM, and so let me solve it. So it would be 6, and here it would be 9 minus, and here it would be 8. So what do we have? We have 1 by 6 as the answer. I caught a mistake here. Actually this would become 16 here, so we would have 16, and then so 16 by 6, so this quantity would be, when you divide by 2, it would be 8 by 3, so that means it would be minus 16, right? So this quantity would be 9 minus 16, so your final answer would be minus 7 by 6. So this is the answer. Okay, so let us move on to our next question here. So question number 2. This states that if vector f is defined to be 2x square plus y square I cap plus 3y minus 4x j cap. So this vector is given to us. Then you are asked to evaluate the integration over C of the vector f dot with dr around the triangle. Now here look at what is your curve C. Around the triangle ABC, whose vertices are given by a 0, 0, B 2, 0 and C 2, 1. So here first of all you have to visualize what is your given curve. So what is C here, the given curve? So we are given that this integral is evaluated around the triangle ABC whose vertices are these. So for that let me first draw this particular triangle. So for that our first point is this one 0, 0. Our second point is 2, 0, right? It would be somewhere here 2, 0, and the third point is 2, 1. So it would be directly above this, so it would be 2, 1. So our triangle would look something like this, right? And moreover we can name these points as given in the question. So this is A, right, and 2, 0 is B, and this point is C. So the triangle around the triangle ABC, so that means firstly we have to start from A, go to B, so this is our direction, and then we are to start from B and go to C, so that means this is our direction, and then we have to start from C and go to A, because we are traveling in the direction of triangle ABC, right? So accordingly this is our path. So this is our path, and let me call it by some other name. So let's call this to be G. So what is a G? It is the path across which we are to perform this integration. Okay. So now in order to perform this integration, what do we require? We are to calculate this over G such that, suppose this is also G, such that the vector f dot the vector dr is to be calculated. Now vector f is known to us, this is given in the question, and vector dr, again we will calculate that. Now this is y axis, this is x axis, we are again in our 2D plane, so therefore your vector r, that would simply be dxi cap, not dxi cap, xi cap plus yj cap, because in x direction it is covering x distance, in j direction, y direction, it is covering y distance. Okay, so if this is dr, then the vector dr would be, if this is r, the vector dr would be the derivative dxi cap plus dy j cap. Now you have all these quantities, so it would be over G, the given vector, which is given to be 2x square plus y square I cap, and then plus 3y minus 4x j cap, this is the vector f, and we are to take its dot with dxi cap plus dy j cap, the vector dr. So now we have to determine what is this G. So accordingly let's define this G. So we can break this whole path into 3 portions. One is the portion AB, another portion is BC, another portion is CA. So I can break this into, before breaking let me just apply the dot product here. So it would be 2x square plus y square into dx, and then it would be 3y minus 4x into dy. So this is our integral. So now what we will do, we will break this whole of this path G into 3 portions. One is along AB, right, this same thing, plus another is along BC, the same thing written over here, plus along CA, the same thing written over here, right? So according to that, what do we obtain over integration? So before that let me define what is this AB, BC and CA. So let's see what these paths are. Now what is AB? AB is this particular line. So what is the equation of this line? Here if you see, you have 2 points, so you can directly calculate the equation for line. So it would be y minus 0, that is equal to y1 minus y2 divided by x1 minus x2, so 0 by 2 into x minus 2, right? So y is equal to 0. So this is the equation of line that you obtain from here for the line AB. For the line AB, or directly you could see that y here is remaining constant, here also and here also. At every point of this line the value of y is equal to 0. So y is equal to 0 is the equation of this particular line. So we have for AB we have y is equal to 0. If y is equal to 0, that means its derivative dy is also going to be 0. And moreover here, what are the limits? Now you see what varies here. The thing that varies over here is this x. So the value of x here is 0 and the value of x here is 2. So that means your x varies from 0 to 2. So this is for AB, right? So for AB I can define this to be x varying from 0 to 2, the quantity this. Now in place of x I am writing x, so it would be clear to you now. So in place of x I am writing x, in place of y I am writing 0, in place of dx I am writing dx, plus in place of y I am writing 0, in place of x I am writing x as such, and in place of y I am writing 0. So this is across AB. Okay. For the next curve, for this curve BC, so let's see what is the path. For the curve BC, here if you look at this, the value of x is remaining same. So from here I can directly write x is equal to 2, or you could use, you have these 2 points 2, 0 and 2, 1, you could use the equation of line to calculate, you could use the formula to calculate the equation of line. Now if x is equal to 2, that means its derivative would be equal to 0. Why? Because this is a constant quantity here. So if you differentiate it, it would be 0. So next thing we have to look at is what are the limits for y. Why? Because we also have to look at what happens to y. So y is shifted from the point 0 to the point 1. So y is equal to 0 to the point y is equal to 1. So basically this integral, this whole integral, this reduces to integration of the values of y from 0 to 1, then the values here 2, instead of x we will write 2, right? Instead of y we will write y, instead of x we will write 0, plus instead of y we will write y, instead of x we will write 2, and instead of dy we will write dy. So this is our second integral, and on a similar lines we can also evaluate it for CA. When you calculate it for CA, it would be, now here look at this, you cannot directly evaluate what is the equation for this line. So you have these 2 points 2, 1 and another point is 0, 0. So when you calculate this equation of line here, it would be y minus 0, that is equal to 0 minus 1 divided by 0 minus 2. This is equal to into x minus 2, right? So you have y is equal to, or 2y is equal to x minus 2. So from here you obtain the equation of line here as, I'm sorry, here you should also have 0 because we are using this point. So it would be this line 2y is equal to x. So we have the line equation of line for CA, that is equal to x is equal to 2y. So according to this, if you differentiate this line, so that means you will be getting dx is equal to 2 dy, and here because we are converting the variable x in terms of y, so that means we will be looking for the limits for y. So what are the limits of y here? The y varies from 1 to 0 here. So we will write it in the same order. It would be from 1 to 0. Okay. So therefore in this case our integral becomes equal to y varying from 1 to 0, right? And the values here for the given function, 2 will come as such. In place of x, what we will write? We will write 2y. So we have 2y whole square. Instead of dx, we will write 2 dy. So it would be 2 dy. And then plus 3y as such. In place of x, we will again write 2y. So 2y. In place of dy, we will write dy. So this is what you obtain after forming all the substitutions. Okay, so our integral is this one. The next step is to solve this integral. So let us solve this integral. Now the first integral consists of only the x values. So if you simplify this a bit, you will get x is equal to 0 to 2. Now this is 2x square dx, and this whole term becomes 0. So this is the first integral. For the second integral, y varies from 0 to 1. Here this whole factor is 0 and this factor is 3y minus 8 into dy. And for the third case, you have y varying from 1 to 0. When you solve this one, you have how many 2's? 4. So 16 y square dy, and then you have, or I can write dy together, so it would be plus 3y minus 8y dy, right? So this is what you have after simplification. So we can perform this integration very easily. So it would be x cube by 3, limits varying from 0 to 2, plus here it would be 3y square by 2 minus 8y, limits varying from 0 to 1 again, plus here it would be 16y cube by 3, and here we have minus 5y, so minus 5y square by 2, and the limits here varies from 1 to 0 and not from 0 to 1. So this would become 8 by 3, and then it would be 3 by 2 minus 8, and then we have when you substitute, we have a negative sign, negative of 16 upon 3 plus 5 by 2. So we can simplify this whole terms, right? So let's see what do we obtain. So when you solve this, you have minus 8 upon 3 plus, when you solve this, you have 8 upon 2, so that means 4 minus 8 is minus 4. So minus 4. So this quantity becomes minus 8 minus 12 by 3. So that is minus 20 by 3. So this is the value of integration that you obtain after solving all the integration. Okay, so I found out this mistake. So here we should instead of 2 we have 2. Instead of x we have 2y whole square plus y square would come, right? And then it would be 2 dy instead of dx, right? So when you solve this, what do you have here? You have 8y square plus y square, that is 9y square into 2 dy, so that is 18y square here. So we have 18 here, so it would be 18 here. This is one thing. Another thing, this 2 is missing over here, so we have 16 here. So finally, after calculation, this is wrong. So after calculation, what do you obtain? So you have 16 upon 3 plus 3 upon 2 plus 5 upon 2, so you have 8 upon 2, 16 upon 3, so minus 2 upon 3 plus 4 minus 8, so this is minus 2 upon 3 minus 4, so this is minus 2 minus 12 upon 3, so that is minus 14 upon 3. So this is your answer. Okay, so I think we can continue more problems in the next video. Well, that is it for this video, so I'll see you in the next one.